Solutions showing positive deviation are actually the solutions which do not obey the Rolle's law, that is, yesterday we discussed about it, for which the partial vapor pressure of any component of the solution is not equal to the product of its pressure in its pure state and its mole fraction. It means that is greater than that of its vapor pressure in its pure state and its mole fraction present in the solution. Similarly, for the partial vapor pressure of the solute, that will be greater than that of the product of PB naught and XB. XB is its mole fraction in the solution. So the solutions that show positive deviation, for that solutions, actually the solute solvent interactions are much lesser than that of the solvent solvent and solute solute interactions, right? For example, if we take the case of ethyl alcohol and cyclohexane, this type of mixture or this type of solution, that is of ethyl alcohol and cyclohexane, actually shows the positive deviation. Why so? Today we will discuss about it, because we know very well in case of ethyl alcohol there is hydrogen bonding in between the ethyl alcohol molecules. Each ethyl alcohol molecule is bonded or physically bonded with another ethyl alcohol molecule with the hydrogen bonding. For example, I am just going to draw it. For example, this, that is any ethyl alcohol molecule, and that is another ethyl alcohol molecule, that is C2H5OH, that is one molecule of ethyl alcohol and that is another molecule of ethyl alcohol. Now these two molecules are physically bonded with the hydrogen bonding. ਇਥਾਈਲ ਅਲਕੋਹਲ ਦਾ ਜੋ ਇੱਕ ਹਾਈਡਰੋਜਨ ਐਟਮ ਹੈ ਉਹ ਸੈਕੰਡ ਇਥਾਈਲ ਅਲਕੋਹਲ ਦੇ ਆਕਸੀਜਨ ਦੇ ਨਾਲ ਹਾਈਡਰੋਜਨ ਬੌਂਡਿੰਗ ਦਾ ਫਾਰਮੇਸ਼ਨ ਕਰਦਾ ਹੈ, ਰਾਈਟ? ਤੋ ਆਈ ਵਿਲ ਡਰਾ ਇਟ ਲਾਈਕ ਦਿਸ C2H5OH or HOC2H5, right? So this oxygen is physically bonded with this hydrogen of the ethyl alcohol, that is named as hydrogen bonding, and we know very well ethyl alcohol has hydrogen bonding. When ethyl alcohol will be mixed with cyclohexane, what will happen? Now cyclohexane will interrupt in this hydrogen bonding. जो थोड़ा cyclohexane होएगा वो इस hydrogen bonding ਨੂੰ ਕੀ ਕਰੇਗਾ? Interrupt ਕਰੇਗਾ. तो ਜਦੋਂ interrupt ਕਰੇਗਾ तो ये bonding weak होएगी. तो it means cyclohexane, देखो ethyl alcohol जो strong hydrogen bonding है, it means BB interactions are hydrogen bonding that is stronger rather than that of AB interaction, and it means AB interactions are less than that of BB interactions, because in case of only ethyl alcohol molecule in its pure state, actually there is hydrogen bonding, that is stronger one. When cyclohexane is added to this ethyl alcohol, or when ethyl alcohol is added to cyclohexane actually, then cyclohexane is non-polar. There are simple van der Waals forces in between cyclohexane molecules. So what will happen? Cyclohexane will interrupt the space between these molecules that are bonded with hydrogen bonding. So it means cyclohexane will interrupt in this space or in this hydrogen bonding, due to which it will become weaker. Now the ethyl alcohol and cyclohexane has no hydrogen bonding, so it means their interactions are lesser than that of the ethyl alcohol hydrogen bonding, as well as cyclohexane simple van der Waals forces. So here the AB interactions are lesser than that of solute as well as solvent interactions. So it means if ethyl alcohol has lesser interactions with cyclohexane, molecules will be easily escape out. So if the molecules will easily escape out, it means the partial vapor pressure of this ethyl alcohol in the solution will be much greater than in its pure state. When ethyl alcohol was in its pure state, it has less vapor pressure rather than this solution state. What's the reason behind that? Because in pure state, actually the ethyl alcohol has strong hydrogen bonding and mole fraction of ethyl alcohol that is present in the solution. So it means AB interactions are lesser than that of AA and BB interactions, due to which, that is, we have proved that the partial vapor pressure of the solute will be will be greater than that of PB naught and XB, and PA cyclohexane partial vapor pressure will be also greater than that of PA naught XA, because in pure state cyclohexane has strong van der Waals forces or van der Waals forces, simple van der Waals forces, and ethyl alcohol has strong hydrogen bonding, and when ethyl alcohol is mixed with cyclohexane, it means it will interrupt in its hydrogen bonding, due to which solute solvent interactions are weaker. So we know very well, to make a solution we have to provide energy. It means delta H will be greater than 0, means this reaction is endothermic in nature, because we have to provide the energy to break the hydrogen bonding that is present in ethyl alcohol molecules. And we know very well the volume on dissolution will be also increased here, because AB interactions are lesser than that of AA and BB interactions. So it means delta V will be greater than 0, because AB interactions are lesser than AA and BB interaction. Similarly, if we take a case of negative deviations. What are the solutions that show negative deviations? Solutions showing negative deviations, actually that solution show negative deviation for which PA is lesser than that of PA naught XA and PB is lesser than that of PB naught XB, because the AB interactions are much greater than AA and BB interactions. Means when two components will be dissolved to make a solution, then these two components will intermixed with a strong bonding rather than that in their pure state. So for example, we can take a case of chloroform. Chloroform, CHCl3, you have ever heard about this? That is chloroform. There is no hydrogen bonding is present in chloroform, because that was a tetrahedral structure, planar tetrahedral structure. And next we will talk about chloroform and acetone, that is CH3 C double bond O CH3. So what will happen when acetone is added to chloroform and when chloroform is added to acetone? Actually, there is no hydrogen bonding or simple van der Waals forces are present in between chloroform, and similar is with acetone. Now, when we will mix the chloroform with acetone to make a solution, what will happen? The hydrogen of chloroform, like this, the hydrogen of chloroform will make a hydrogen bonding with the electronegative oxygen of acetone, CH3COCH3, right? So it means there is hydrogen bonding, that is bonding stronger rather than that of in their pure state. So AB interactions are now greater than that of AA and BB interactions. Means ਜਦੋਂ ਆਪਾਂ solution ਬਣਾਇਆ ਤਾਂ ਜੋ ਆਪਣੇ solute ਸੀ ਔਰ ਜੋ ਆਪਣਾ solvent ਸੀ ਉਹਨਾਂ ਦੇ ਵਿੱਚ strong hydrogen bonding ਹੋ ਗਈ। ਪਹਿਲਾਂ ਤਾਂ ਕਿਸੇ ਵੀ type ਦਾ hydrogen bonding ਨਹੀਂ ਸੀਗਾ, ਪਰ ਜਦੋਂ ਆਪਾਂ ਦੋਹਾਂ ਨੂੰ mix ਕਰਤਾ ਤਾਂ ਦੋਹਾਂ ਦੇ ਵਿੱਚ hydrogen bonding ਹੋ ਗਿਆ, and hydrogen bonding is stronger bonding rather than that of simple van der Waals forces. So AB interactions are stronger than AA and BB interactions. So it means what will happen here? It means PA will be lesser than that of PA naught XA, and PB will be lesser than that of PB naught XB. It means their vapor pressure in the solution form will be lesser than their pure state. So it means they will less escape out due to the strong hydrogen bonding. So it means the energy will be released here because strong hydrogen bonding is going to form here. So it means delta H is less than 0. It means that is an exothermic reaction. And what about the volume? Delta V on upon mixing will be less than 0. MIX means mixing to making a solution. Volume will be decreased here. because in pure state there was less bonding, so it means they can easily escape out, right? But in case of solution form they can easily escape out. So it means if they can't escape out easily, it means that is exothermic reaction. And delta V is less than 0 means volume is going to decrease, because volume increases when intermolecular interactions decreases, and the volume decreases when the intermolecular interactions increases. So volume is actually inversely proportional to the intramolecular forces, right? अगर मॉलिक्यूल स्ट्रोंगली हेल्ड होणगे तो क्राउड ਜਿਹੜਾ ਹੈ ਯਾਨੀ ਕਿ ਆਪਣੇ ਕੋਲ ਵੋਲਿਊਮ ਹੈ ਜਿਹੜਾ ਉਹ ਘੱਟ ਆਕੂਪਾਈ ਕਰਨਗੇ, ਬਟ ਅਗਰ ਉਹਨਾਂ ਦੇ ਵਿੱਚ ਆਪਣੇ ਕੋਲੇ ਜਿਹੜਾ ਹੈ इंटरमोलिकुलर फोर्सिस वीक हैं तो ज़्यादा वॉल्यूम ऑक्यूपाई करेंगे। बिल्कुल उसी तरह जैसे गैसिज हैं उन्होंने इंटरमोलिकुलर फोर्सिस घट होंगे है इसलिए ज़्यादा वॉल्यूम एक्वायर करते हैं, बट जिमें सॉलिड ने उन्होंने टाइटली पैक होंगे है तो वॉल्यूम घट होंगे है। सिमिलर केस अपॉन मिक्सिंग अगर उन्होंने बॉन्डिंग स्ट्रोंग हो जाती है फिजिकल बॉन्डिंग तो इट मीनस उन्होंने वॉल्यूम डिक्रीज़ हो जाएगा, और अगर बॉन्डिंग है जी अगर वो वीक हो जाती है तो वॉल्यूम इंक्रीज़ हो जाएगा, राइट? सो दैट इज़ द इम्पैक्ट ऑन वॉल्यूम एंड energy change, right? For what is the difference between the solutions that show positive deviation and negative deviation? So first one was definition, that for these one AB interactions are lesser than that of their pure state components pure state, and for negative deviation the AB interactions are greater than their pure state, right? Second difference is their partial vapor pressure increases, positive deviation Pa will be greater than that of Pa naught XA for same for solute, but here Pa will be lesser than that of their product in their pure state, that is Pa naught XA, right? Third one is for the solutions that show positive deviation delta H will be greater than 0 यानी कि positive यानी कि endothermic, and here delta H will be less than 0. And fourth, delta V upon mixing will be greater than 0, here delta V upon mixing will be less than 0. Upon mixing volume will decrease here, upon mixing volume will increase here.